The unit that we are beginning with lesson 6.1 is all about radioactivity, and this lesson is about something that radioactivity is, ionizing radiation. Radiation and radioactivity are perhaps two of the most misunderstood terms in all of science. Now, okay, maybe that's a little overdramatic, but I want you to think about this for a second. When you turn on a light, does it radiate energy? If it does radiate energy, does that mean that there's radioactivity being released from that light? Or what about when you use a microwave oven? Is it safe to say that a microwave oven uses radiating microwave energy to heat up your food? Is there radioactivity in a microwave oven? Or what about the word radio? We know that radio stations have huge transmitters that transmit radio waves. That word radio appears in radioactivity. So a transmitter at a radio station radiates energy, but is it also radioactive? Hopefully, through this lesson, I can help you distinguish between radiating and radioactivity. And the way that we're going to do that is we're going to look at 6 different terms related to radioactivity and radiating energy after we first learn the definition of what it means to radiate energy. Let's get started on our lesson on ionizing radiation and radioactivity. Now, first off, again, we're going to take a look at the definition of radiation. And it's important for you to know radiation is a very general term. It just means that energy is being emitted from a single point of matter somewhere. It could be a hot piece of metal radiating energy away from it in all directions. It also could be a light bulb radiating light. Radiation could also refer to radioactivity, which radiates energy as well. Now we're going to look at what makes something radioactive versus just radiant. The first thing we're going to do actually is talk about radioactive radiation. When something is radioactive, it's releasing high energy particles or high energy waves because its nucleus is breaking down. Radioactive means that the nucleus of an atom is breaking down, and that's why energy is being released. So when there's radioactive processes going on, because energy is emitted, there's also going to be radiation. But they're not the same thing. Radiation could refer to any energy being given off and transmitted from a source, whereas radioactivity refers specifically to an atom's nucleus breaking down. There's also non-radioactive radiation, which is electromagnetic radiation that's given off when matter gets heated or electrified. Non-radioactive radiation is energy being given off from a source, but it's not being given off from a source whose nuclei and atoms are breaking apart into different atoms. So that's the difference between radioactive, where atoms are breaking down, and non-radioactive radiation. But there's 2 more sets of terms I want to look at to fully understand this. The next term to understand is particle radiation. High energy particles that are emitted from the source in all directions. When I say particles, I'm talking about protons, neutrons, and electrons. Pieces of atoms are shot out at really high speeds, and we call that particle radiation. The energy is being carried by parts of an atom. There's also non-particle radiation, but we've already learned about this type of radiation before. We called it something else. We called it electromagnetic radiation. And sometimes radioactivity can give off electromagnetic radiation. If radioactive processes release electromagnetic radiation, it's always the really high energy electromagnetic radiation. We'll talk about that in a second. I just want to point out that non-radioactive radiation can never be particle radiation. It's always electromagnetic, which means it's pure energy being given off from a source. A light bulb gives off light because its electrons are being excited. So it radiates light in all directions. That's electromagnetic. Hot lava gives off infrared radiation because it's so hot and it's emitting that energy in all directions. That infrared radiation is electromagnetic. In fact, here's a list of all of the forms of electromagnetic radiation that we've learned about before. The lower energy forms of radiation, with radio waves being the lowest energy and ultraviolet the highest of that group. But it's the other two forms of electromagnetic radiation, X-rays and gamma rays, that result from radioactive breakdown of atoms. Because when nuclei and atoms break down, it just releases a ton of energy. More energy than can be contained in radio waves or microwaves or light. It has to be in the form of X-rays or gamma rays because there's just so much energy there. All right. The last two terms I want to take a look at are ionizing radiation, which is what this lesson is really all about, is radiation that is so high energy, it's able to somehow change the number of electrons around an atom, and therefore it changes the way that those atoms are able to bond with other atoms. It has the potential to break atoms that are bonded apart from one another. And that's what makes ionizing radiation so dangerous. You are made up of atoms bonded together. So ionizing radiation that is absorbed by you can cause your atoms to break apart and unbond from one another, which can have devastating effects on the human body. All particle radiation is ionizing radiation because particle radiation has a huge amount of energy as these high energy protons, neutrons, electrons, groups of those are flying away from the atoms. It's also true that high energy electromagnetic radiation is ionizing as well. And that includes gamma rays, which have enough energy to cause electrons to leave an atom, or X-rays, which also have that amount of energy. Non-ionizing radiation is just the opposite. It's lower energy radiation and it causes atoms to heat up and move faster. Non-ionizing radiation, though, doesn't really harm the human body the same way that ionizing radiation does. It doesn't break apart the molecules that make up our DNA and our cells. Non-ionizing radiation is always one of the lower energy forms of electromagnetic radiation. Okay, this is a lot of terms, and I'm going to encourage you to pay attention to all of these and really let these sink in. Now let's take a look at what ionizing radiation actually looks like. Ionizing radiation can come in two different forms: particle radiation, which we talked about, and electromagnetic radiation. Remember, all particle radiation is ionizing, and the only way to get particle radiation is through radioactive decay, when the nuclei of atoms break down. These are pictures of the different particles that can be released when atomic nuclei break down. And then electromagnetic radiation can sometimes be ionizing if it's X-rays or gamma rays, but if it's the lower energy forms, it's not ionizing. Here I have a picture of a carbon atom. Now remember, carbon is one of the most abundant types of atoms in the human body. If this ionizing radiation enters a carbon atom, what can happen? One of the electrons just flew away from the atom. If this carbon atom was bonded somewhere in the human body, it has now changed its bonds with other atoms around it. Now, here's the deal. The human body can react in different ways to radioactivity. Number one, cells can die. And it's not really a big deal if a couple of cells in the human body die. Number two, the cell can change, but the body can repair it. If that bond gets broken between two carbon atoms, the body is capable sometimes of putting those atoms back together and repairing it without any negative impacts. But here's the problem with ionizing radiation. Sometimes if it causes damage, but not a lot of damage, cells won't die, they'll just change the way that they're bonded. And when that DNA gets copied because the cell reproduces, that change to the DNA also gets copied into the new cells that the body makes. And when that happens, when your DNA changes because of ionizing radiation, there's a chance that that can cause things like cancer. Please make sure you understand that ionizing radiation can be particles or electromagnetic with a lot of energy, in fact, enough energy to cause electrons to change in an atom.